Hi folks, so this is the second part for this manual to electronic side mirror conversion. In this part I'll be talking about the electronically controlled side view mirror, how it functions, what are the connections, and without any further ado, let's just start with this project. So I ordered this side view mirror electronically controlled with blinker from partbigboss.com. The packaging is very nice. It's a Ghaziabad based startup, and they packed the item very neatly. They also painted the item in taffeta white color, and it arrives in like 6 to 7 days after ordering. I will put the link in the description form where you can order part compatible to your vehicle. So as you can see, the packaging is very solid. They put a lot of bubble wrap. I procured one pair, left and right, with the blinkers, and post ordering they will give you the courier tracking number as well, so that you can find out where exactly your part is. So here it is after removal from the packaging. The painting is also okay, not great, but it's okay. These are some wires which I'll be detailing later. So after opening, this is the left side electronically controlled mirror, and that's the body of the mirror with the blinker on it and painted with the taffeta white color. That's the mounting side, exactly similar to your original rear view mirror. It's an aftermarket product, and it has been built with the details, and it has been dispatched with the proper care. Even the mounting hardware cap is also on. Total 3 hardwares are there which are required to mount it with the vehicle. It has total 5 wires. These 3 wires are for the motors, and 2 wires, the red and black, are for the blinkers. It also comes with the gasket. So let's see these wires in detail. It has 3 wires for mirror control and 2 wires for blinker. The 3 wires which controls the mirror are black, second one is blue, and the third one is yellow. Then we have basically these 3 will control the mirror function, and then remaining 2, the red and black, these 2 wires are for the blinker control, that you have to connect to your indicator, and when you turn your vehicle right and left, they will blink. While these black, blue and yellow, basically one should be common, which one we will find out in the video, and one would be responsible to control up and down, and one would be responsible to control right and left mirror function. To find out how these wires will be connected, it is important to understand how these mirror functions, and let's draw one simple motor with a shaft here, and 2 terminals, terminal A and terminal B. Now these terminal can be fed power supply. So let's make a small table. Here I am writing the wire detail, then the supply, like positive and negative, and third is the outcome from the motor, whether it will rotate clockwise or anti-clockwise. So we have wire A and wire B. Let's feed plus 12 volt to wire A, and B is connected to ground. In that case, the outcome would be motor can rotate in clockwise direction. The shaft will move in clockwise direction. Second possibility could be that A can be connected to ground, and B can be connected to plus 12 volt, like just reverse the polarity. And by doing this, the rotation would be anti-clockwise in direction. So let's write the motion as anti-clockwise, and the first one is the clockwise. Now if a mirror is attached with this shaft with the small gear arrangement, by feeding this supply and switching it, you can have your motion either in up direction or in down direction, depend upon how A and B's are getting their supplies. That's the way to understand how the mirror function, and how by changing the supplies between A and B we can very easily move the mirror in up and down direction. Now consider another motor with again a shaft coming out of it, and two terminals like C and D, and just like the table which we made here, we can make another table for terminal C and D. We can feed C and D to plus 12 volt and ground in first case. In this case, the motor will again rotate into the clockwise direction. So let's write clockwise here. And if you feed C and D ground and 12, means just switch the power supplies, it will rotate in anti-clockwise direction. By switching the supplies, motion can be controlled, and if you connect this motor through a gear assembly with the mirror, you got left motion and right motion depend upon the supply. So by this we can have up, down, left and right control with the help of only two motors, and by changing the polarity of the supply. So the 4-wire terminology of A, B, C and D can be further reduced into 3 wires if you simply short B and C and take out a single connection out of it. Then you have A as one connection, D as one connection, and B and C shorted, and then it can become the third connection. So that's how we have seen 3 connections are coming out from the rear view mirror. You can feed A and B plus minus or minus plus, it will control up and down direction. Similarly, between B and D, you can feed minus plus, it will control right side, and it can have plus as well as minus, it will control the left side. Now this ABC with the BC common and D terminal is right now need to be fed to switch so that it can control the motion. Then we have a blinker. Blinker has simply 2 wires, it's a LED, nothing else. It has a red terminal and black terminal. Red is positive, black is negative. Let's start with the left mirror. It has black, yellow and blue. I'll be feeding plus 12 volt supply to black connection and minus to yellow, and we will record what is the motion of the mirror, and in this case it is going down, as you can see. Now let's switch the supply to reverse and keep writing it. So first combination was black was positive and yellow was negative, and mirror was going down. Now we'll switch the supply and we'll put negative to black and positive to yellow, and the motion should be in upward direction, and here it is. One motion is sorted out. The black and yellow are responsible for up and down control. Now second combination is black and blue. So in this case also, let's feed black to positive and blue to negative. Now it is turning towards left, as you can see. Let's record it also. The black is positive and the blue would be negative to control the motion towards left. Now let's switch the power supply, feed negative to black and positive to blue. In this case, mirror should move towards right direction. So that's how I figured out the left mirror. Similarly, it can be done for the right mirror as well. So now we know black is the common wire for left mirror, and then rest two are yellow and blue. So it's time to connect the remote switch with these mirrors and do a trial run without putting it into the vehicle. I have connected temporarily the mirror with the remote switch, of course right and left both. Let's select to the left side mirror, and then by pressing a key you can see it is moving towards right this time, and up if you press up it is going up, and if you are pressing down it is going down. So same way right mirror is also tested before mounting it on the vehicle. So all the motions are checked and polarities are verified, and so here it is, all the connections sorted out. Now I will be putting the general purpose connectors with these rear view mirror terminals, so that I can plug it easily and disconnect it if at all required. All the connectors are right now soldered with the rear view mirror connection for proper contact. So all the rear view mirror terminals are right now soldered and taped with the general purpose connectors, and they have formed a kind of harness for left and right rear view mirror. You can see the connector here. You can easily plug it and remove it if at all you need it. And you have also seen this remote control switch in my last video. Entire harness is totally based upon connectors. You can remove and plug any element as per your choice. Now the armrest panel needs some modification because readily trim parts are not available. So existing part need to be modified. Here I will make a cutout where this remote switch can be inserted from the back side and can be fastened. You can see the remote switch. It has two parts. One is the up and down left and right switch, and second is the top left and right selector switch. So one stencil is required to be made. You can make on any piece of paper. Just measure the dimension of the switch and make the circle and oval. Or if you have a computer, you can make this thing very neatly, and whatever black areas are there, that you have to remove it with the paper cutter, just like this, and then try to insert the switch in this stencil, and if it fits good, then you take a printout of multiple sheets. And this part requires some measurement. Armrest removal is very easy. From the corner you just insert a credit card or plastic part and just pull it up. It will come out, and flip side you can see a connector. That connector you have to remove by pressing a small tab on top of it. So for panel modification we need few things here. Of course the switch, knife, scissor, M-seal, and industrial adhesive. Then we need multiple stencils, then a multiple diameter drill bit up to 30 millimeter dia. It's very important part. Then the grinding bits, 14-15 millimeter dia, cutters. Then we need this panel and drill machine. Let's start the modification by removing all these ridges with the grinding bit. It is important so that whatever stencil which we have made, that stencil can be glued flush, so that drilling can commence in a proper way. So with the help of this grinding bit I have cleared the entire area, and now I am going to use this multiple diameter drill bit to create a hole for the up and down left and right key. Up to 30 millimeter diameter is used, and you have to just position this drill bit into the center and use the drill machine to create the hole step by step. I'll be using this small grinding wheel and this one to create the proper oval shape for the up and down and the left and right selector switch. It's a very nice tool to have in general purpose applications. So now I have attached this stencil with the help of the super glue, and there is a German saying, measure twice, cut once. So the measurement should be pakka, and then you can gently start the drilling. Drilling is a very simple process. It's a plastic, cuts very nicely. That's how it looks after grinding and removing of the material. Here it's from top side, pretty neat cut. And let's fix the switch. It's a trial fixing, and it looks like a OEM fit, very neat, no gaps whatsoever. You can also see some adhesive is put inside the switch, so job well done. So you can see this is the remote switch. It has two holes for nut and bolt mounting. So I have marked the location where the bolt will come, and in this location I'll be putting two plastic pieces with big holes, and in that big hole the hardware will be engaged, and then on top of that with the help of nuts I'll be mounting this remote switch. These are the two plastic pieces. I have made two holes. You can see the large diameter hole where the head will be engaged, and then by flipping it, it can be attached on the back panel. This is the screw. So this is after the engagement. You can see the head is properly engaged, and then I'll be applying the super glue and then attaching it like this on the back panel. So plastic to plastic adhesion of super glue is ultimate. This is the arrangement. You can see after putting the super glue, it is very well attached. You can see I have also torqued the nuts also. Some adhesive I have applied inside this switch, so that individual connectors are attached there firmly. Switch is very easily, pressed just like OEM switch, and all the keys are functioning well. So this is the modification into the panel. You can see the still photograph, and now I'll be showing some of the photograph of this panel before doing the modification and after doing the modification.